guys, this feels pretty weird. It's like I haven't seen you guys in forever, which I haven't. This is the first of the 3 little videos you're gonna watch kind of as we do our review here, breaking it up into kind of the 2 biggest units I wanted to focus on for this review session. Since we have so little time and I want to focus on the big chunks, let's not get lost in those little things that are not going to count as much on the test. So I just wanted to remind you guys that this is the order of importance on the test. The energy unit is the biggest unit and the biggest portion of the test, followed by dynamics, momentum, torque. Quick note there, though, that in our textbook, if you're looking at the textbook, it's unit 6 in our textbook. It's unit 7 on AP Classroom. So if you're confused by that, if you're like, hey, this stuff isn't talking about torque and rotation, the textbook versus AP Classroom, that unit is different for some reason. And then kinematics is actually the smallest unit of the ones we got to. This is still a decent chunk of the test. But kinematics was our like position, velocity, formulas, time lists, all of those. So if you feel like you were still good with those, that's good, because you might not want to spend too much time on that. It's the least important of the units that we got to. Now, Unit 3 and Unit 6 we did not cover in class, but I did post material from AP Classroom, as well as, again, those 2 are a very small portion of the test. If you're looking at your textbook, and if you didn't remember this, I told you guys at the beginning of the semester that they changed the AP Physics test moving forward from here, that this is it. Everything I have listed here, including Unit 3 and 6, that's the test. So 8, 9, and 10, they took off because it was just way too much content. It's been that way for a long time. So I wish I had known this way back when, but that's kind of where we're at. Again, what we're going to focus on today for this review session is energy and dynamics, and just a basic review of those 2 to hopefully kind of just get you guys in the mindset of, okay, let's start bringing this stuff back, focus on these little details, and go from there. Before we do, though, I just want to remind you guys a couple things because it's been a while. So you're just going to kind of follow along. Again, I posted if you wanted to print this out, if you could, you can fill in the notes as you go, or just take your notes as you see fit as you go through these videos. So I just want to remind you guys of our universal units, because again, conversions can get you sometimes. If something is not listed in one of these units, we have to do a conversion. So I just want to remind you guys that for mass, that's M, in all of our equations. The universal unit for that is a kilogram. So if we're going through our problems and we don't see kilograms, if we just see grams, we have to do a conversion, right? So we have to keep an eye out for that always. Time is T, there we go. And this is always seconds. So once again, if we see minutes or hours, we have to do that conversion in our calculations, because we need to have all of our answers to get full points on this stuff in terms of these basic units. Distance, same thing. D or X, actually, sometimes, especially if we're talking about position. But that's, again, meters. So once more, as you're going through any of your review problems or review material, you have to make sure that everything is in these units. Otherwise, you're going to be losing points, or possibly even just getting the wrong answer altogether. Now, all of our units, we have some other special units. They're actually combinations of these, right? We've got newtons, we've got joules, we've got watts. They're all combinations, actually, of these things. Now, if you're doing a for response, for example, and you can't remember what the units are supposed to be for something. So, for example, we're going to talk about energy in a little bit. If you can't remember the units for energy, what you can do is leave it as that combination without saying, oh, it's joules, right? Actually, that's the units for energy. And here's what I mean by that. This hopefully is an easy example, but it says, what is the force of gravity acting on a man with a mass of 50 kilograms? So hopefully we can remember this. You guys remember what force of gravity is acting on somebody? Hopefully you did. Force of gravity, and we'll refresh this later. This is the last video we're looking at today, is mass times gravity. Now, if you didn't know that the units for force, what are the units for forces again? Do you remember that? Newtons, right? So if we didn't know that newtons was the units for force, what you can do is, based on the formula, use those units. So this is M And g, we know, is an acceleration, right? G is the acceleration due to gravity. So you can use those units. So what we have here is a 50 kilogram, that's the mass. Gravity is going to be 10. What you do have to remember the units for this, but because it's acceleration, that's 10 meters per second squared. So what this becomes is 500, 5 times 10. And then you can leave this as kilograms times meters per second squared. This is a Newton. Again, a force is, this would be 500 newtons. However, if it's a free response and you're just blanking and you're like, I can't remember what the special unit is for forces. I can't remember what the special unit is for momentum or for anything like that, right? If you know what the units are for the individual variables, then you can just leave it as those units. So once more, as you're going through your review, obviously you want to recall, oh, energy is joules, power is watts, so forth and so on. But we'll want to make sure that we are focusing on that. There we go. That was smart sounding. Okay, the last thing I wanted to refresh your guys' mind here, I totally forgot to make these blank, but whatever, it's fine. Scalar and vectors. So remember that a scalar quantity only has magnitude, meaning size, and a vector quantity has direction. If you think of a vector gun being like a vector gun shooting off into a direction. There's tons of different scalars and vectors. These are just some basic ones. Again, distance does not have a direction, because if I said, oh, I was 5 miles from here, that's no direction, right? That's just a distance. Or I walked 10 miles. I could have walked 10 miles in a circle and you've got no idea. Displacement, though, would be like, I'm 5 miles east from here, right? Because it has a direction. It tells us where we're going. Same thing with speed. I'm going 5 miles an hour. That's speed. I'm going 5 miles an hour to the left. That's velocity, right? Or at an angle of 30 degrees. Acceleration, same thing as a vector. Time and mass, scalars. Mass is obvious, but that is considered a scalar quantity. Mass has no direction. So just wanted to review those two concepts again. Scalar versus vectors, would be careful when we're working with vector and vector combinations. We need to make sure we understand what the direction is as well. So I just want to start there. Again, this is just your first little intro video to go over some basic concepts that we haven't seen in a while, maybe, or maybe you have if you've been reviewing. From here, we're going to look at energy a little bit, just a very quick refresher of energy, and then work through some problems together.